Hi guys! Now we're going to go through example 4 from your notes, continuing on with using Avogadro's number, molar mass, moles, all of the mole relationships that you looked at in your notes. So example 4 asks, how many moles of oxygen are in 116.4 grams of carbon dioxide? So again, what I did to start was I circled what I'm trying to find, I underlined my given. That's just going to help you when you're looking back at the question, find the information that you need. So the problem is asking us to find moles, and the problem gives us 116.4 grams of carbon dioxide. This is a word problem. Okay? Put it into formulas. Carbon dioxide, CO2. So I have 116.4 grams of CO2. Now, when you're given grams, first find the molar mass. Right? Before you even set up dimensional analysis, find the molar mass. That's going to help you. So CO2 is 1C plus 2 oxygens, which is 32. When you add those up, you get 44.01 grams per mole. That could be useful. That's why I found that. So we know our given, we know what we're trying to find, and now we know the molar mass. So what I did, set up your given information. Put your given by itself with units. Okay, you have to include units. Not including units could be a hindrance for you as you work through dimensional analysis. So we have 116.4 grams of CO2. Now what I did first is I just set up my dimensional analysis problem with only units. I'll go back in and I'll plug the numbers in after, but for now I'm just going to include the units just to make sure I've got everything set up correctly. So I have grams of CO2 on the top. That means grams of CO2 need to go on the bottom. My units need to cancel. Well, if you're going from grams, the only thing that you can go to is moles. So I'm going to go to moles of CO2 on the top. Then once I have moles of CO2 on the top, I'm going to have to cancel that out, right? I'm not trying to find moles of CO2. Remember, I'm trying to find moles of oxygen. So my moles of CO2 are going to go on the bottom, and I'm going to put moles of just oxygen, just O, on the top. So we double check, grams of CO2, moles of CO2, I'm left with moles of oxygen. Now, if we look at the bottom, I plugged all of our numbers in. We start with our given. Okay, when you're going grams to moles, you use molar mass. So for every 1 mole of CO2, we have 44.01 grams of CO2. Okay, now going from moles of CO2 to moles of O, just look at the formula. Right? For every 1 mole of CO2, I have 2 moles of O within that. And you can also think about it in terms of molecules and atoms. Right? For every 1 CO2, I have 2 O's. So then we multiply across the top, divide by what's on the bottom, and you get 5.2897. Okay, that's this number in parentheses. Now, if I look at my given, that's 4 significant figures. My answer has to have 4 significant figures. So when I look at this 5 is significant. Okay, I'm just going to count over. 1, 2, 3, 4. Okay, I need to round to my thousandths place. Okay, well, this is a 9, and the number next to it is a 7. So this 9 needs to round up. That's how I get 5.290. And remember, trailing zeros are significant when it's in a decimal. So I have 5.290 moles of O. Okay, so if I have 116.4 grams of CO2, I have just over 5 moles of oxygen.